Let's talk a little bit about initialization. In the previous video, we talked about what it means for a variable to be declared, what it means for a variable to be defined, and saw how often we have both a declaration and a definition in the same statement. So in that example, we declared this variable of type int named count, and we saw that this actually qualifies as a definition as well as a declaration because it sets aside memory for the variable. Specifically, it causes the compiler to set aside a chunk of memory corresponding to the width of an int, which can vary from platform to platform, quite frankly, which is something we'll talk about in another video. And of course, it associates that chunk of memory with the name count. We also saw in that video how we can later place a value into that location. But what if we wanted to supply count with an initial value at the same time we're declaring it? So for example, we already have a starting value, or we wish to supply maybe a default value. Well, that can be done through initialization. There are actually several techniques we can use in C++ to initialize a variable. First and foremost, the recommended way to do it is called list initialization. You may ask, why is this called list initialization when there's only one value there, right? That's a reasonable question. Well, you could view the 5 as a list of one element, if you wish. And in another video, when we come to examples of containers with more than one element in them, we'll see that the same syntax can indeed be used to initialize those containers. Indeed, this is one of the virtues of list initialization syntax. It's a consistent style of initialization that can be used in multiple contexts. This style was introduced relatively recently into the language, C++ 11 to be precise, and has the additional benefit of preventing accidental narrowing conversions. So for example, if I tried to place the value 5.7, which is a floating point value, into this int variable named count, what would we expect to happen? Well, with list initialization syntax, if we go to build the program, it's going to give us a compiler error. The compiler is not going to allow us to make this narrowing conversion, which is actually a good thing. Whenever possible, we'd like to be informed of our mistakes so that we can fix them. You can also use a similar style. This again is still uniform initialization syntax, aka list initialization syntax. It's just an alternate version of it. So you can use it with the assignment operator, the equal sign, or you can use it without. Another style you'll likely be familiar with if you've programmed in Java, for example, or C, is the one we took a glance at in the previous video. So you can go ahead and just use the assignment operator and place the value 5 over into this int variable count. This style, though, does allow for the narrowing conversions that we discussed a moment ago. That could be bugs in our program. So for example, if I said 5.7 should get stored over into count, and then I go to build the program, it's going to let me do it. And what would happen here, right? Well, as you may guess, what's going to happen is the 0.7 is going to get truncated. It's going to get sliced right off the 5, and the 5 is going to get stored over into count. And maybe I don't realize that happened. Maybe it was a mistake, and that's going to be a bug in my program. Now, I'll admit that a lot of us have gotten used to this older style over the years, and so just as a matter of habit, we often use it from time to time, and you'll see me use it sometimes in these videos. The important thing is to be aware of the different styles that you can use for initialization in C++ and what their pros and cons are. And frankly, in the interest of full disclosure, just because I don't want to hide the ball on anything, there is technically one more style. As you can see, this is reminiscent of a function call, and this actually works in C++, but frankly, I don't recommend it. All things being equal, this is actually the newer and preferred syntax. Okay, so we've taken a look at some ways that we can initialize variables in C++. I suspect you'll find as you go along in your studies of C++ that there are often a number of different ways to do things. The language tends to like to give programmers their freedom of choice. Sometimes that can be beneficial depending on your preferences. Other times it can be it can just feel like one more thing to learn, right? But it's important for you to at least be able to recognize the different variations, and then you'll settle in on a preference or two for how you'd like to do things.